Our next section is interval estimation. In point estimation, we found that an estimate will be proposed for the unknown parameter based upon a sample of size n taken from that population. If x1, x2, etc. xn represent the variables drawn to the sample, based upon this x1, x2, etc. xn, we propose an estimator, and value of this estimator obtained from the sample taken, then that value is known as the estimate for the population parameter. So when samples are changed, definitely the values of the estimates also will be changed. In interval estimation, we propose a range of values which is likely to contain this parameter of the population. So here we propose a set of limits t1 and t2 in which the true value of this parameter will be located. So normally we consider these intervals such that the parameter appears within those limits with a pre-assigned probability. Such intervals are known as confidence intervals, and this value of pre-assigned probability is known as degree of confidence or confidence coefficient. We denote this confidence coefficient using 1 minus alpha 100%, and its most commonly used values are 90%, 95% or 99%. The meaning of 1 minus alpha 100% is that if we construct 100 such confidence intervals, among them 1 minus alpha 100% cases, the parameter will belong to the proposed intervals. Now we consider different cases of confidence intervals for different parameters. The first case is for confidence interval for population mean. So this case is considered when sigma is known. Sigma represents standard deviation of the population, or sigma is another population constant, another parameter. So our aim is to determine those population parameters. So normally they will be unknown. But if we are able to identify its value from the past experience or from other resources, we take it as sigma known. So the first case is construction of confidence interval for population mean when sigma is known. For that, we consider the sampling distribution of sample mean taken from a normally distributed population. So in sampling distribution, we discussed that the mean of a sample taken from a normally distributed population has normal distribution with mean mu and standard deviation sigma by root n. That is, x bar follows normal distribution with the mean mu and standard deviation sigma by root n. So making use of this property, we construct a confidence interval for population mean when sigma is known. Since x bar follows n mu sigma by root n, using the standardization principle, we have x bar minus mu divided by sigma by root n follows n01. That root n is the denominator of the denominator. It will come to the numerator. Thus, we have x bar minus mu root n by sigma follows n01. Now, this statistic is used to construct in a confidence interval for population mean. Suppose 1 minus alpha 100% is the confidence coefficient. So here we have to obtain two limits t1 and t2 such that the parameter of the population mu lies within those two limits t1 and t2 with a probability 1 minus alpha. Then we get this mu within two limits with probability 1 minus alpha, or this t1 and t2 can be considered as a confidence interval or interval with the confidence coefficient 1 minus alpha. For that, we take probability of t1 less than mu less than t2 equals 1 minus alpha. Now, from tables of standard normal distribution, we can obtain the value of t alpha by 2. Here, this statistic follows standard normal distribution. So here, this is the point minus t alpha by 2, and this is the point plus t alpha by 2. So this minus t alpha by 2 and plus t alpha by 2 are little bit shifted from their exact positions. They must be at at this place. Okay, I shall take the pencil and relocate those t1 and t2, no, t alpha by 2 and minus t alpha by 2. So this is the exact place of minus t alpha by 2, or from where the shading will be starting, t alpha by 2, and here this is that plus t alpha by 2, and in the middle we get 0. So probability of minus t alpha by 2 less than or equal to t less than or equal to t alpha by 2 is 1 minus alpha, which means that from this minus infinity to minus t alpha by 2, the area will be 1 my alpha by 2. And here this area also will be alpha by 2. That is, the total of the unshaded sector's area will be alpha, and the shaded sector area will be 1 minus alpha. That is probability of this shaded sector starting point minus t alpha by 2 to the shaded sector ending point plus t alpha by 2 area is 1 minus alpha. Now middle variable t is now replaced by the statistic proposed x bar minus mu root n by sigma. So minus t alpha by 2 less than or equal to x bar minus mu root n by sigma less than or equal to t alpha by 2 equals 1 minus alpha. Now we do certain simplifications here. We can multiply throughout with the sigma by root n and then add minus mu minus x bar everywhere, mean in all the limits, so that mu only appears in the middle. Thus, the confidence interval is x bar minus t alpha by 2 sigma by root n and x bar plus t alpha by 2 sigma by root n. So these are the lower and upper limits within which this mu will belong, or it means that mu within these two limits has a probability 1 minus alpha, which means that the degree of confidence 1 minus alpha has been satisfied by the limits x bar minus t alpha by 2 sigma by root n and x bar plus t alpha by 2 sigma by root n. So when we have the fixed values for t alpha by 2 for various confidence coefficients, that is 1 minus alpha 100% equal to 90%, t alpha by 2 will be 2.52, and if it is 1 minus 1 minus alpha 100% is 95%, t alpha by 2 will be 1.96, and if it is 90%, t alpha by 2 will be 1.645. These values can be obtained from the tables of standard normal distribution. The next situation is sample small and sigma is unknown. Okay, in that context, we make use of another statistic, that is statistic following student's t distribution. So we have this t equals x bar minus mu root n minus 1 by s, and it follows student's t distribution with n minus 1 degrees of freedom. Here we note that in this equation that sigma is not present, means we don't need the population standard deviation for constructing confidence interval here when sample is small in size. And as before, we get these two limits t alpha by 2 minus t alpha by 2 such that probability of these two limits will be 1 minus alpha. And next we replace that middle variable t using the present statistic, that is x bar minus mu root n minus 1 by s, and it is certain mathematical simplifications are done here so that we get the two limits as x bar minus t alpha by 2 s by root n minus 1 and x bar plus t alpha by 2 s by root n minus 1, and these are the confidence limits when sigma is unknown and sample is small in size. The next is the confidence interval for population proportion. Here P star is taken as the sample proportion and P is taken as the population proportion. So using a result of binomial distribution tends to normal distribution, we have this property that T equals P star minus P divided by root of P into 1 minus P divided by n follows n01. So again making use of the same principle, probability of minus t alpha by 2 less than or equal to t less than or equal to t equals 1 minus alpha, we have this equation, and the middle variable t is replaced by now p star minus p divided by root of p into 1 minus p by root n less than or equal to t alpha by 2, so it will be 1 minus alpha. As before doing certain mathematical simplifications, we get the confidence interval as P star minus T alpha by 2 root of P star into 1 minus P star by n, and P star plus T alpha by 2 root of P star into 1 minus P star by n. Here, this is the probability statement giving the P within two limits with a probability 1 minus alpha. So these are the two limits actually, but in the two limits we have the unknown value, unknown proportion P. So that P unknown, since P is unknown, it is estimated using sample proportion, or we can replace this P by sample proportion P star. That's how we get the confidence limits as P star minus T alpha by 2 root of P star into 1 minus P star by n, and P star plus T alpha by 2 into root of P star into 1 minus P star by n. So these are the three cases of confidence interval we consider here. That is confidence interval for population mean. In two cases, sigma known. Then second case is sigma unknown but sample small. And the next is the confidence interval for population proportion.